Yes, good morning everyone. How are you all? I hope you all are well, fine. Okay, so again today we are back with the chapter 16, which was symmetry, reflection and rotation. Okay, so yesterday what we have learned was all about the concept of symmetry and the concept of line symmetry, or how we can say that an object or a shape or a figure is symmetrical or not through the concept of a line symmetry. And then we discussed about one more, that if the subject or if any object of any figure is not symmetrical through the concept of line symmetry, then how it can be symmetrical if it is rotated about a point, or how it is symmetrical about a point which is understood by the point symmetry. So, we have discussed about the symmetry, line symmetry, axis of symmetry and the point symmetry. So first let us have a quick revision of that, and then we will be proceeding with our new topic or the new explanations. So let us have a discussion about the line of symmetry. Okay. So what was line of symmetry? It was the line which divides a given figure into two identical halves, and it is known as line of symmetry or as an axis of symmetry. For example, this is a figure. Can you see this arrow? Now this arrow is divided from this midpoint or by this mid dash line. So this dash line is known as line of symmetry, and this dash line is also known as axis of symmetry. That means if I fold this arrow about this point, these first part and the second part is going to overlap each other if I fold it along this line. Is that clear? So we have a line of symmetry with various shapes and with various figures. We have a symmetry with some of the English alphabets. Let's go with that. What are those? A, M, U, V, W, Y, T, B, H, K, O, D, X, C. Can you see in some of the English alphabets, we have vertical line of symmetry. That means when we have drawn vertical lines, the two parts which we got in them is exactly symmetrical. And in some of the figures, can you see we have vertical line of symmetry? That means if I fold these below figures about their vertical line of symmetry, horizontal line of symmetry, or the upper figures along their vertical line of symmetry, the two parts or the two different figures are exactly going to overlap each other. So this is not that it only occurs with the English alphabet. There are many solid figures which possess the phenomena of symmetry about a line. So here we have some of the solid objects. For example, we have a cone, we have a bomb-like a structure, we have a sphere, and we have a cylinder. So can you see, with this cone and a bomb-like structure, we have a vertical line of symmetry, and with the sphere and the cylinder, we have a horizontal line of symmetry. And this is what we have discussed yesterday. Then, moving on to many more new topics that we have discussed or that we are about to discuss is how we can say that some of the plate figures are symmetrical. See, in the previous section what we have discussed was how the solid figures were symmetrical. So here we have this rectangle shape, triangle shape, addition shape, square shape, or the concentric circle shape. So they are also symmetrical, either about a vertical line of symmetry or a horizontal line of symmetry. Then here is a pamphlet just to test your knowledge or what you understood from the previous sections or from the previous explanations. It is, if a line divides a figure into two identical halves, then the line is said to be. For example, this is my palm. Can you see the line which divides? Okay, this is the line which divides. So if I fold these two palms along this line, can you see they are completely identical and overlapping? So we can say that the line about which we folded the two palms is the line of, that what we have to answer. So here the same question is asking, if a line divides a figure into two identical halves, then the line is said to be the line of partition. Is it a line of symmetry, or it is a line of rotation, or it is a line of transformation? So I hope now, after so many explanations, now you are able to answer this simple question. Now here is the solution of the previously asked. If a line divides given figure into two identical halves, then we say that the figure is symmetrical. If you fold it along that line, what we say, that the figure is symmetrical. And the line is called axis of symmetry, or the line of symmetry. And here again a beautiful picture of a butterfly, and which we have the two parts, we have divided it by a line, and this vertical line is a line of symmetry. Alright. Now moving into the line of symmetry for some more figures. The line of symmetry for some more figures, or for some extra lines or shape. Here we have a line of symmetry for a line segment. Can you see this is a line segment? Okay, this is a line segment. I think now it is clear. This is a line segment. Okay, and this line segment also has a midpoint. We know that every line has a midpoint. Okay, why we call it as midpoint? Because from that midpoint, the distance from one end from the one end from that midpoint to the other end from that midpoint is same. If the distance is same, then the point is said to be a midpoint. So similarly, if I talk about this particular line, about the line segment, it also has a line of symmetry. And how we are going to obtain the line of symmetry in the case of line is by drawing a perpendicular bisector. Okay, and in the chapter of construction, we have already learned about how to draw a perpendicular bisector. Alright. So this is a symmetry for a angle. Okay, by bisecting the angle, we can get a line of symmetry. Again, for an equilateral triangle, by bisecting the medians, we can get the lines of symmetry. Here, the lines of symmetry for a square. Okay, the diagonals. And the line of symmetry, let me tell you, for the square, we have the vertical lines, we have the horizontal lines, and we have two diagonals as well. Okay, so for various figure, it is for regular pentagon, and for regular hexagon, for a rhombus, and for a kite, which is an example of a rhombus, for isosceles trapezium, for a semicircle, for a circle, and so on. So can you see, we have seen the line of symmetry for so many figures. Again, let us go back to all those figures. Here, the line of symmetry for a circle. Here is the line of symmetry for a circle. Okay? Line of symmetry for a circle. Then the line of symmetry for a semicircle. Here is the line of symmetry for a semicircle. Then it is a line of symmetry for isosceles trapezium. Then we have a line of symmetry for a kite, which is in the shape of a rhombus. Here we have a line of symmetry for a rhombus itself. Okay, here is the line of symmetry for a rhombus, the diagonals. Here we have a line of symmetry for regular hexagon. Regular hexagon means hexagon having 6 sides with all sides equal. Then it is known as regular hexagon. Then here we have a line of symmetry for regular pentagon. Regular pentagon means 5 sides such that the measurement of each sides are equal. Then we have a line of symmetry for a square. Alright, since a square has 4 sides, so we have 4 lines of symmetry. The 2 diagonals, 1 vertical and 1 horizontal. Okay, then for an equilateral triangle, equilateral has 3 equal sides. So for this equilateral triangle, we will have 3 lines of symmetry. For this angle, we can draw the bisector of the angle and we can get the line of symmetry. So here we have different figures or the different shapes with their respective line of symmetry. Alright. So here again I think there is a question asked, which geometrical figure has exactly one line of symmetry? It is asking which figure has exactly one line of symmetry, and the option is it a rhombus? Is it a circle? Is it an equilateral triangle? Or is it isosceles triangle? So in circle, we can have a infinite lines of symmetry. Okay. For an equilateral triangle, we have three lines of symmetry. Then for an isosceles triangle, since we have only two sides equal and the base is not equal, then yeah, for isosceles triangle we have only one line of symmetry. So these are the respective solutions given. Okay. So here three line of symmetry, and then yes, for isosceles triangle we have only one line of symmetry. Alright. So I think this line of symmetry with terms of all the plain figures, solid figures and alphabets are clear to you. I hope you understood with this video. Keep on watching the video. We will come with more explanations of symmetry. Thank you.